Again, go ahead, sit with me to create something great. Now, today we are going to be touching on our AI agent side of the things, right? We're going to be using Cursor in order to build an AI agent, right? And this AI agent is going to review our Algo bots that we're going to be reviewing our MeanieBear bot, right? We're going to be reviewing our LottoBaby, our BelairBaby, and our Sniper. A-G. So I spelled it right. You're like big tripping. All right, so LLM equals a large language model, and a large language model is just another way of saying an AI chat model, right? An example would be OpenAI's ChatGPT, right? You have Anthropic. You have Claude, right? They also have Opus. They also have Haiku, right? For Google, I can spell. We have Gemini. We also have Flash. And these are just the model names, right? So these are there. So the first one, this OpenAI is the LLM provider, right? This is the LLM model. So ChatGPTs are their models. So ChatGPT 5, 4.5, so on and so forth. Anthropic has a Claude model, an Opus, tomato at this point, and Haiku model. Google is Gemini and Flash. Let's just throw one more up here. I know Perplexity. I'm not gonna hold you. I know there's Sonar. Let's just go pull it up real quick. So Perplexity AI models. Okay, there's Sonar Pro, Sonar. So everything is just Sonar. So we have Sonar Pro, Sonar Reasoning, right? And then Sonar Deep Search. So I'm just gonna put Sonar, right? Per Let me spell that right. Perplexity. All right, beautiful. And we do have our AI bots running, right? So let's just go over this real quick so you can understand what's going on. So all of these bots are running in our terminal. So what does that mean? We're running them. If you ever seen a terminal, right? So this is what one looks like. If I just to get what a blank one for you. So I open the terminal. Okay. And what you're just looking at is Claude Code, but we're going to get into that, so don't worry. So here are the rules, right, for the this particular algorithm that trades. Remember, 0 DTE SPY options. So we're looking for a breakout, right? And this is looking for a breakout within the past 5 bars, right? Within the past 5 minutes, and we have a volume confirmation. Now, once we get towards the tail end of after creating our agent, I have another strategy that I want to create, and this is going to be super risky, oh, while I'm saying that, this is not financial advice. This is merely educational. If you do seek financial advice, I'm going to create that today, matter of fact, here on the screen too, after I'm done with this agent. I was saying I need to create a disclaimer, or we're going to create that here too. There's going to be a lot of coding, so just buckle up with me. But nonetheless, I'm going to create a disclaimer. This is not financial advice. If you do seek financial advice, please reach a CFP, a certified financial planner, a financial advisor, or those that are licensed. All right, let's get back to this thing. So again, I have another strategy that I want to do is a breakout without the volume. So I want to see, or like a very low barrier to entry volume. So let's talk about the rules for this particular algorithm, right? This rule is saying, all right, we have to profit 100%, up to 100%. Now, sometimes we do hit the 100%, right? If you've been following the back test, you will see like hitting 100%, it ain't easy. Excuse me, it is easy, but it's just a matter of being able to mitigate your risk, right? So we have a stop loss of 35%. So what is a stop loss telling us? A stop loss is telling us that, hey, we're starting all of our strategies. Every single one of our strategies, until otherwise told, is starting at $100. The reason we're starting at $100 is because I want to dispel the notion that you need thousands of dollars in order to trade options. You don't, right? And what we're doing is that we're being very particular about the option contracts that we're trading, right? We're trading options that are super liquid. So what does liquidity mean when it comes to options? Liquidity means being able, once you buy an option, you have somebody on the other side that is going to, that you can sell it to, right? And once you are ready to buy an option, there's somebody on the other side that is going to sell it to you. So liquidity is basically letting us know that there is somebody on the other side in order to help you with the transaction, right? Whether you're buying or whether you're selling, right? So we want to be able to trade into an option, and SPY is a very liquid option, or a very liquid access, or very liquid ETF. And remember, ETF is, I feel like I'm speed talking right now. Hold on. All right, my fault. I feel like I was speed talking, so I just went to go grab some water real quick. But nonetheless, if y'all want me to slow down, or if you're not understanding what I'm saying, I'm not talking fast. You just listening slow. But nonetheless, I'm gonna try to slow down. But I do talk fast by nature, right? So you always have to deal with me on that part. All right, let's keep riding. Yeah, we want to be able to dispel the notion that you need thousands of dollars in order to option trade. I don't believe that. I do believe you can do this very intentionally, being able to start with $100. So until otherwise told, you can assume, and I know what they say about assumptions, but you can assume that all of our strategies, and I'm going to let you know, are starting with $100. So in this example here, what a stop loss lets you know is that, okay, if we're starting at $100, if at any point in time, right, the strategy dips to $65, sell, sell, sell. So if we're in a call, sell it. If we're in a put, sell it, right? And the difference between the calls and the puts, right? Remember, a call is we're bullish, right? Horns up. We think that the market is going to go up, right? So call, bullish. What does a bull have? Horn. What does a horn normally go up, right? So bullish, up, right? We think that the market is going to go up. Now, if we're buying a put, a bear down, right? So we think that the market is going to go down, right? That's how I learned it. I learned it from an old white guy. I ain't gonna hold you, but it stuck. So that's what I'm going to give it to you. But nonetheless, so that's when with respect to our stop loss, right? So our stop loss is a risk mitigation, right? It's a way for it to be for our algo rules, right? Whenever you're trading, you want to be able to make sure, yeah, it's nice to have a bot that does all this for you, but you want to make sure you be very, very specific with your rules and don't assume. I just told you to assume, but I'm now telling you don't assume. Bruh, follow me, don't follow me, but follow me. That 35%, right? So that 35% is letting you know, if we're starting at 100, if at any point in time we get down 35%, sell, sell, sell. Do not hold us in that position. A trailing stop loss is letting us know that, okay, once we're in the position, right? And if we are up, let's say 100%, right? But it drops, we want to be able to sell it, right? This is going to activate. So it's like another barrier protection for our stop loss, right? So what it does is once we're in the position and we're up 50%, this is going to activate, right? And then at any point in time, if it goes to 49, then it's going to automatically sell, right? So we can automatically lock in our wins. So a stop loss protects us from being able to lose our position within the account. A trailing stop, right, is to make sure that we protect our gains, our profits in the account. So once we are up 50%, a trailing stop is going to activate, right? Then at any point in time, it gets down 20%, right? Then we're going to sell. Now, this is a bit tighter, and it's a bit more adaptive, but nonetheless, see, it was at 30%, now we're at 20%. And that allows us to be a little bit more flexible, right? So we have almost like a 30% delta, a difference within here, right? So another rule is saying you can only hold every option contract for 15 minutes. Now, because these are 0 DTE options, meaning these are option contracts that expire the same day, this algo or these set of rules are saying that every bet that you place or every investment that you place, we are only holding it for 15 minutes, and we've seen great performance off that, right? Again, our min and our max delta, you could only buy from 15 delta from 15 to 35, and you could only buy maximum of 44, right? So these are an example of rules, right, that we have for an algorithm. How it works, you define your strategy. Buy or call when SPY breaks above the last 5 candles, and volume is 3.5 times the average. Code logic, you write your code in Python or another language, but normally you write it in Python. And you use data feeds, and our data feeds are using Theta Data. I'm not sponsored by them, but hey, if you want to throw me a bone, throw me. I'm here. We also use Data. We use IBKR. We do use Alpaca, and IBKR is just interactive broker. Feed in live data like our VIX. We get in our VIX from CSNBC, and then our Greeks again from Theta Data. Signal detection, right? Risk management. We talked about that, and then automation. The bot does all of this repeatedly, right? So here's an example. So our bot is done running here because it's 11:40. So what I'm going to do is stop this process. There's a couple more that I need to stop because it's 11:30 and most of them are done trading. Now, this one trades until 44. So it's about 4 more minutes. So let's let that run. You're done. Okay, you don't need a sheet dot. Let me come here. We can stop you. All right, who else can we stop? And I believe you go into 44. What time do you go until? 44. All right, so you have another 4 minutes or so. So we have 2 more bots that are running. Here we go. So let's get that back to proper. So you can see both of them. Beautiful, fam. All right, so we have those running. And again, if you do have any questions while I'm doing this, please let me know. All right, so now we're going to come here. So we talked about an algorithm, what that is, right? Now we're going to be making an AI agent, right? So, and this AI agent is going to be using an LLM. An LLM is just a large language model, right? And the different type of chat models that we're going to be using, I don't know. I primarily may use ChatGPT and Anthropic, but hey, I may throw Perplexity in there, right? With Sonar, I may throw Google with Gemini and Flash, right? There's also Gronk. Gronk, right? And Gronk's, I'm not going to hold you. Don't let me lie to you. Gronk models. I know it's some like llama. Okay. So it's primarily llama. So Gronk equals llama, right? And then we have Mistrial. Mistrial, I think, is like, I'm not gonna. Mistrial is just another provider. Mistrial model. Um, okay. So there are models like Mistral Medium, Mistral. I'm. You do that on your own, Seb. So I normally use Mistral Medium or Mistral Small. So I just put Mistral Medium. All right. So what we're going to be doing, AI chat model and then AI provider. So you can see the difference here, right? So what we're going to be doing is creating an AI agent that reviews the bot's logs, backtest. Remember what a backtest is, right? A backtest equals putting our strategy in a time machine, historical data. I'm going to fix that. And gauging how well it performs on that data. So what I'm going to do, I'm just going to do that. And then you do, okay, that's probably a bit too, or maybe I just do this so you can still see that. All right, let me get my spellings right. All right, so a backtest equal putting our strategy in a time machine, historic data, that's fine. Historic data, and then gauging how well it performs on that data, right? So we backtest on 2024, 2022, 2023, so on and so forth, so we can see how well our bots, right? MeanieBear, Lotto, Belair, Sniper, right, performs within these backtests, and it's been very, very well. So if you want to see an example of a backtest, let me show you. MeanieBear. That's fine. So let's open up a log. And again, this is cursor. This is just another like open window within cursor. But I'm going to be creating a new one. That's why you see this blank one here. But I want to show you an example of a backtest, right? So this is our backtest for our MeanieBear. We talked about the rules, right? I was playing around because normally I like to optimize, and I know you can optimize using bt.optimize and other Python libraries, right? And this code is written in Python. And Python is a coding language, right? There's JavaScript, there's R, there's TypeScript, there's C++, there's a lot of coding languages, right? But mainly for me in my house, right, I use Python. It's a lot easier to be able to learn. It's primarily used when it comes to being able to algorithmically trade or creating AI agents. Now, an AI agent could be one of two things, right? It can be a RAG agent, and a RAG agent is a retrieval augmented agent. And all that means, right? Let me just write that real quick. To review backtests and then recommend. Let me just write that. Recommend. Um, recommend changes or any other updates based on the review. Any other updates recommend on the. All right. So let's put a RAG agent. So what we're building is just an AI agent, right? So this AI agent is just going to be connected to an LLM and reads logs and then outputs. And I know that's super simple, but we're going to go into that a little bit more so you can understand. So this agent is connected to an LLM, it reads logs, and then it outputs what we want based on that logs, right? So a RAG agent, the difference between an AI agent, so these are still AI agents, right? This is just another type of AI agent, right, is a RAG agent, right? RAG is retrieval, augment, generation, right? For retrieval. Let's see. Goodness gracious. Retrieval fam. There we go. Pinecone is just another place. I'll get to Pinecone. I'm glad that was brought up. Retrieval. Okay. Give me a second. Okay, there we go. Thank you. Retrieval augmented generation. This is RAG. So what that basically means is that this is an agent that sits on top of a database, right? This database is called a vector store, right? And this vector store is a type of database that is all binary, right? Meaning all numbers. So what a vector store does is that it'll take, for an example, let me show you a log. So it'll take, for example, this log, right? This log is easy. We can read this log, right? But computers like to read with numbers, zeros and ones, so binary, right? So what it'll do, it'll take this log and then it'll create. So it's a 3-step process, right? So step 1 is to create chunks, right? And then chunks are just broken down pieces of the data / file, right? So what it'll do, because this right here is relatively small, so that you don't need to chunk it that much, maybe 1 or 2 maximum. But let's say if we were here, right? You saw how this one was only 64 lines of code, right? But let's say if we have another one that is 5,000 lines of code, then you want to chunk it up, right? Then you want to break it up into these small pieces, right? So we're going to create chunks, right? And a chunk is a broken down pieces of the data / file. And then the second step, so step 2, is to turn those chunks. Hold on. So step 1, we create chunks. Step 2 is we got to create vectors. Hold on. Let me just make sure I'm not tripping. Can you explain the RAG process to us? Chunks, and then you take your chunks and then you create embeddings. That's what the fuck it is. Embeddings. You turn the chunks into embeddings, right? Embeddings. And those embeddings are those. Oh, goodness gracious. Please tell me it has the embeddings here. Okay, we talked about the retrieval augment generation. So AI searches a database, and that database, again, AI searches a knowledge source, and that knowledge source is a database. So it could be PDFs, web pages, a database, or research reports, or past trading logs, right? And it finds the most relevant information to your question, right? What is the perfect strategy for high volatility markets? It fetches the recent VIX data or volatility studies, right? Then it augments. The AI adds those retrieved facts to your question, and it basically builds context so it understands exactly what is going on. So it's like saying, hey, here's the question plus some helpful background. Generation. This is when the LLM comes into place, right? So the first 2 parts is, all right, it has to go into the vector store, and these vector stores have embeddings, right? If I can spell embeddings right. Goodness gracious. Embeddings. Goodness gracious. Embedding. Right? And an embedding equals binary numbers, binary ones and zeros. Let's just put ones, and I put ones and zeros. numbers that the AI LLM chat model can easily read and process. So step one, we create chunks, right? That's breaking down the pieces, break down the, let me just put this, break down, broken down, break down the data slash file into manageable pieces. So chunks, break down the data slash file into manageable pieces. Step two, we're going to turn those chunks into embeddings. And embeddings equals a binary number, ones and zeros, that the AI LLM chat model, large language model, right, can easily read and process. And then step three, store in vector store, right? And a vector store equals a type of database that is filled with embeddings. Remember, embeddings are just numbers. Embeddings. All right, perfect. So, vector store. All right, so let's go back to our little explanation here. The AI searches the not. Okay, we got that. Finally, the AI writes the answer using both what it knows and what it found to give you a precise evidence-based output. So instead of guessing, it's referencing real data. So you can say, hey, let's build an AI assistant for your algo trading system. Here's how RAG can do it. I'm not going to build the RAG agent. RAG agent is a little bit overkill for what we're doing, so no need to do that. What we're going to build is just a regular AI agent. Can you talk about the difference between an AI agent and a RAG agent? So RAG agent, retrieval augmented generation, is a specialized type of AI agent designed to fetch and use external knowledge before responding. It is great. Is great at looking things up like documents, APIs, databases, data, then reasoning over what it finds. I get it, bruh. In short, RAG equals let me search first, then answer. Example, if you ask what was SPY average implied volatility this week, right? A RAG agent retrieves the live market data from the API or database, then generates a summary answer based on it, right? What is an AI agent? An AI agent is a broader concept. It is any system that can perceive, reason, and act to achieve goals autonomously, right? That means it can decide what to do next. It calls tools or APIs and collaborates with other agents, and it plans multiple steps. It is less about retrieving facts and more about thinking, deciding, and doing. For example, an AI agent might check your market conditions, run your strategy logic, execute trades via API, adjust stop loss automatically. It is not just generating text, it is taking real action. So the key difference is that an AI agent, it takes action or makes decision. Core strength is planning, reasoning, and tool using. External data, sometimes it'll use tools or APIs, right? Output, action, tool calls, or workflows. Example use, execute trades, manage portfolios, or schedule tasks, right? A RAG agent is retrieve. I'm going to get the dumb facts first, then I'm going to summarize. So get facts, then summarize, right? Contextual understanding and factual accuracy. Always retrieve its core step, so it's using the vector store. And an example of a vector store is Pinecone. I like to use Pinecone. It is one of the most it's free, and you know it's for me. And the amount of data that you get for being able to start with them is a ridiculous amount. Compare plans. Hold on. I'm not sponsored by them, but hey, if you do want to sponsor me, shout out to the boy. Again, for the starter plan, you're getting 2 gigs, right? That's a lot. And you can do a lot with this RAG data, right? But again, we're not building a RAG agent. Maybe one day I'll build a RAG agent so you all can see that process of that. We're just building a regular AI agent, right? Here's how they work together. They're complementary, not competing. For example, a RAG agent fetches real-time spy data, news sentiment, and then technical indicators. An AI agent uses that data to decide whether to buy, hold, or sell. Think of the RAG as the researcher. You know what? I have to stop our bots because they're still running and we're past time right now. So what I'm going to do, you can stop. There's one more that we have to stop. Oh, it stopped by itself. Oh, no, because I stopped it. There's one more and then you. Because 11:44 passed, it's damn near noon. So these bots don't need to run anymore. All right, perfect. And I'm glad we're able to run it live today. And now we're going to create an AI agent that is going to assess their performance, right? So, all right, let's keep going. A RAG agent fetches the real-time spy data, news sentiment, and or technical indicators, right? Technical indicator being like a moving average, a MACD, Bollinger Band, so on and so forth. A AI agent uses that data to decide whether to buy, hold, or sell. So think of a RAG as the researcher and the AI agent as the decision maker or trader, right? In a trading context, a RAG agent pulls the last 7 days of SPY option data, summarize the volatility trends, and then implied skew. And then an AI agent, based on that summary, opens. So you may know what? I may be building like a hybrid. It's going to have a little bit of RAG in there, but it's primarily going to be an AI agent, right? Because it's retrieving the facts, right? I'm giving it the logs, right? And then it's going to make information or make decisions based off those logs. So based on that summary, open a 0 DTE call spread of volatilities between 5 and 13 VIX, and trend is bearish. Remember, bearish, bear down. So what did I think the market is going down? All right. So we have our difference between, you know what I want to do is take this little chart and I'm going to use it next time. Home. Perfect. And then stores sit on top. Okay, perfect. Key differences, an AI agent, and then a RAG agent. You know what I should have done? All right, I'm going to do that later, so you all don't need to worry about that. So what we're doing, oh, let me show you the back test. I know I'm bouncing everywhere, but I just want to show you a back test real quick so you can see a back test. Let me show you a back test. All right, I want to run our back test on our MeanieBear. And remember, all of our strategies start at $100. So let me show you a back test. We are throwing the strategy back in 2004, I believe. Yep. So we're throwing the strategy back in 2004. These are the rules for the strategy that it has to follow, right? These are the rules for the algorithm that it has to follow. We wrote the code in Python, right? So now it's going to load the data that it needs. So it's going to load the Greek. You try to do something 10 million times and tell me how long that takes you, right? So it's loading all the Greeks. It's calculating the DTE, days to expiration, and then it's filtering the DTE. Then after filtering, this is kind of a redundant step because we only pull 0 DTE, but whatever. That's why you can see the number is the same. But whatever. Then it's going to start the back test. Then our back test is running. So our first trade was positive. Right now we're at 188. I'll just wait until all of our trades start at $100, right? I'll just do month in, right? And then we'll just follow the month in. So at the end of January, we are at $600, $607. Again, all of our trades start at $1. You only trade once per day, so we don't overtrade. So we're in February right now, about mid-February. We're at 1,200, 1,700. At the end of February, we are at $2,273. So I'm just going to say month end so I can make it a little bit easier. We're about halfway out of March, right? And March, we're at 3,600 right now, about midway through March. And then the ending of March, we are at 4,020. So we're averaging about 1,000 a month. We're in May right now. We are in, no, excuse me. Can I count? We're in April. We're about halfway through April. We're at 10,000. We're oscillating back and forth between 10 and 9,000. We just got out of April. We're at 10,000. Now we are in May. As you can see, 15,000, 17,000, halfway between May. So that was a big jump, right? From the 1,000 a month to now almost like 3,000 a month. That you saw a trade, one trade, $1,600, right? We held it for 5 minutes. This was a call, right? Call, we're bullish, right? Bull's horns go up, right? We bought this call for $17, right? Stop loss 34%, $34, right? Excuse me, $11, 35%. Cost per contract is 17. We bought 100 contracts. That cost us $1,700. We sold it for $1,600, right? 100%. 100%. I told you 100% returns aren't hard, right? So this is our back test. We're running it on 2024. Right now we're at 55,000. That's crazy. We started at $100, fam. $100. So I just want to let that be known. We're in August. Right now we're at 64,000. August is at 64,000. So I remember we're oscillating between like 8 and 10,000. So during the summer, while I was explaining that, the summer almost made like 20, 30K, bruh. That's another high trade. I just saw a $3,300 trade. So you all are seeing this too live. We're running a back test on our strategy, and this strategy is a momentum breakout strategy that buys 0 DTE options. So these are type of strategies that we create all day here on the channel. So, and I'm probably going to create another one here with you live, and as soon as I'm done with the 100,000. We just crossed 100,000, fam. We just crossed 100,000, and it's October. 112,000, and it's October. This is starting at $100. Who would want an algo that starts at $100 and then gets to $126,000 without you having to ever replenish it, fam? With the algorithm knowing how to buy, knowing when to sell, knowing how to manage his bag, right? Did you ever see it go broke? I didn't see it go broke. Did you see it go broke? We're at 139,000, and it's November. So we're getting out of November. We are at $138,536, right? Remember, we started at $100, right? So we're in mid December right now. We're at 139,000. We just crossed 145. We just crossed 145,000. We're at, okay. So the strategy for the year did 173 trades. Its final balance was, and again, just so you can see, there's no, what do we start at? All of our strategies start at $100, fam. So we started at $100. We did 173 trades. We ended at $143,265.68. That's about 143% return. Who wouldn't want that, right? Let's look at Sharpe ratio. Sharpe ratio is about a 0.5. Now, normally I try to do a Sharpe ratio. Excuse me. Now, normally I try to do a Sharpe ratio that's anywhere between like 0.75, maybe even 1. Like, I don't aim for 2 because I'm not raising money, right? If somebody was raising money, then you would want a Sharpe ratio of like 2, 2.5, 3. Those are hedge funds. Those are individuals that are raising money, raising a fund, right? I'm not doing that. I won't do that. I'll teach you how to create an algorithm, right, that can get you these phenomenal results, right? But I will never raise money. That's too much of a fucking headache, bro. Max drawdown was 34%. So it touched the stop loss, right? Our stop loss is 35. So this strategy at one point in time was at like $64, right? And then it was able to rally to 145, 143. That's ridiculous, fam. Win rate is 63%, so it's not a coin toss, right? It's just under 2/3, right? So if for every 2 out of 3 bets is getting right, for every 2 out of 3 trades is getting right. Best trade was $6,632.91. Worst trade was 2017. Was that a bad year? Was 2017? Yes, it was. 2017, 09 was the worst trade. Average trade made $827. Average hold time was 10 minutes. Average ROI is about 125%. Profit, that's phenomenal. I didn't see that before. Profit factor is 4.60, meaning that for every dollar we put out, we get $4 back, almost $5 back, homie. The way the trades exit, there were 13 stop losses. We lost about 15,000 in those stop losses, so about 7.5%. 112 time stops. So those trades held to the full 12 minutes, right? That was about 64% of the trades. That made about 72,000, right? Profit targets, right? That was about 12% of the trade. Those made 63,000. And then trailing stops, that was 15% of the trades, 26. Those made 23,000, right? So this is an example of a back test. So what we're going to do is create an AI agent, right? And it's also going to be an AI agent with a bit of RAG elements, meaning going to review our logs, backtest. I'm just going to say BT equal backtest, right? Our log backtest and underlying algo code, then provide recommendations based on the review. Now, this may be multi-module, right? All that means is using multiple LLM providers to get this job done. Meaning, what I'm thinking about, multi, goodness gracious. All right, what I'm thinking about doing is using Gemini. The reason I'm using Gemini is because Gemini is known to be able to handle large data sets, right? Oh, you know what I should have explained? Mother freaking, what is a token? Because this is something we need to watch out for. So what is a token? You know what? I never really understood that either. So I would like us to be able to. Can you explain what is a token and how it works for LLM chat models or AI agents? Always had a question about. All right, so what is a token? In the context of an LLM, a large language models, right? Tokens are essentially a piece of text. It can be a word, a part of a word, or even punctuation. So for an example, ChatGPT is awesome. It might be split into 4 tokens. ChatGPT is awesome, right? So a token can be a word, a part of a word, or even punctuation. So a token, I'm not going to do that. What is a token? It can be a word, a part of a word, or even a punctuation, right? So our example. So think of tokens like Lego blocks of the language, right? Model builds sentences, paragraphs, or answers by arranging tokens in order. So how tokens work in LLMs? Input, when you type a prompt, right, the LLM converts it into tokens. So for example, what is the SPY's option price? So this is an example of how it's going to break it down. So it's almost like chunking, right, in a sense, right? I think it is chunking. I'm sorry, I want to say almost, because I'm not an expert when it comes to this coding thing. Like when I first started coding, right, I learned AI agents. I learned RAG agents. I learned how to be able to like manipulate them in different frameworks, right? Whether it be LangChain, whether it be Crew AI, right, shit like that. But I didn't. This is what I know. This is my wheelhouse. But I've only been doing this since August. If I was doing this since August, would you listen to me? But even worse, I've been only doing it since April, April of this year, right? So about 6-7 months that I've been doing this. There's a couple of cool projects that I've created and a couple that I haven't shared with you all yet that I want to. So what I'm going to be doing, just show you all my process on how I create AI agents algo code, machine learning, anything when it comes to coding, right? I want to show you all my process on how I do it. And if I'm able to do it, you're able to too. So this isn't hard. I'm going to demystify this and make this super, super easy. So antibody, fam, antibody who has that aspiration to code, you can code, right? Don't let a blank screen stop you. You see me? All right. Let's keep going. So that's I was talking about this maybe be chunking. I think it is chunking. Processing. The model predicts one token at a time using probability to guess the next token in the sequence. That's why the output flows naturally. The model keeps predicting until it hits the end token. The output is the model converts the predicted token back into the text so the humans can read it, i.e., we can read it. Why tokens matters for AI agents and cost. Most LLM providers, right, OpenAI, Anthropic, Google, so on and so forth, charge by the token, not by the word, right? So both the input and the output are both token counts. So if your prompt is 50 tokens and the response is 150 tokens, we're paying 200 tokens. We got to pay for 200 tokens, right? And the cost of tokens is not that egregious. I'm not going to hold you. There's a way that we're going to mitigate this. So that's why I'm going to create this multi-module instead of just one. Because if I were just to feed this, so for an example, if I were to feed 5,000 lines of code to ChatGPT, yo, that's not, that ain't, and it's all depending on the model, right? Each model has a different cost. Each provider has a different cost, right? So if you were to feed 5,000 lines of code, I don't care what now, Gemini, Google, I don't know how, but they are a pro at being able to take, this is like lunch food. This is like 100 lines of code to them, right? So they're able to take it, synthesize it, and then output it. So what I want to do is have a multi-module LLM provider, right? Let me finish reading this. So I want to do is have a multi-module LLM provider, right? That we're going to have ChatGPT, or excuse me, I keep saying messing up with that, but whatever. And we're going to have Gemini handle the large data sets, right? So it's going to take this log, process it, get it ready for the next LLM to use it, right? So let's just finish this and then I'll explain it. I know, bro, get off my neck. Most LLMs, OpenAI, Anthropic, charge by the token, not by the word. We talked about that. Tokens and AI agents. When you use an AI agent, like a trading assistant or a multi-agent system, we're going to kind of create this here, but it's going to be multi-module, multi-model, right? Not multi-agent. And you're going to see. Each agent's instructions, context, and retrieved data can be converted into tokens before being sent to the LLM. If the agent has memory, right, past messages or data, that memory is also counted as tokens, right? Large context or a lot of retrieval, more tokens, more cost, slow processing. So takeaways, tokens are the building blocks of are the building blocks of languages for AI, artificial intelligence. LLMs predict one token at a time to generate answers. The input plus the output determines the cost and the context, right? The cost and the context limits, right? And the AI agents must manage the tokens carefully for efficiency, especially with RAG setups where retrieval adds extra context, right? So what we're going to be doing, again, multi-model, using multiple LLMs to get this job done, right? So Gemini is going to handle the data set. We're going to have OpenAI, or let's just do Chat GBT. Now, again, there's different models. The model that I'm going to be using here is, what is it? O4 or O03 mini. Now, the reason I'm using O4, and let me see how I can bring this up without like sharing sensitive information. Hold on, homie. Model, OpenAI. Okay, bet. Here you go. Here you go. All right. So what we're going to be using for ChatGPT is, and again, these are their models. Remember, every LLM provider, OpenAI is ChatGPT, right? Every LLM provider has their own models. What we're going to be using is the O3. There's O4. I'm not using that one. Where is it? Okay, O4 Mini. So this is one we're going to use. So let's read on this one. So the O4 Mini is fast, cost-efficient reasoning model succeeded by the ChatGPT 5 Mini, right? O4 Mini is the latest small O series and is optimized for fast, effective reasoning with exceptional exponentially efficient performance in coding and visual attacks. It's succeeded by the ChatGPT 5 Mini, right? So this is the price. So the price is going to be, and I kind of hate this. I kind of wish they would do it like per. So it's per 1 million, right? And we're going to be using it via an API. And what an API is, it's like, can you explain API? Super simple. Quickly so we can get it. Application programming interface. Okay, yeah. Application programming interface. Think of this like a waiter at a restaurant. You, the app, tell the waiter you want a request. So the waiter goes to the kitchen, the server, and then brings it back to you, your food, the response. So in tech terms, your program asks another program for a service or data for or an action. That API defines how you ask or you respond to it, right? For example, you want the SPY option prices. API, your bot sends a request to give me the SPY option data. The server returns the data in a format so your bot can read it like a JSON. That's just an output format, right? An API are just messengers between programs. They let you use someone else's service without knowing the internal code. Somewhere you see apps talking to each other, that API is at work, right? So API, application program interface, right? So that's primarily how we're going to be using. So an API is basically the keys to those servers. So API keys, right, are keys to those servers so we can get that information. Each one of these models here, where is it? I'm tripping. Am I tripping? I'm not tripping. Are you tripping? I'm not. Okay, there we go. Each one of these models here has an API keys, right? You don't share your API keys, and I'm not going to share my API keys. You share your keys with nobody, right? Why? Remember, we're paying for the tokens. Do you want to pay for somebody's tokens? Like, I don't know y'all like that. I'm not going to hold you. Like, I'm not paying for your tokens, and I don't want you to use my tokens, right? So we're going to be using API keys, right, in order to use these LLMs. And I can show you. I mean, it's easy to be able to get the API key. What I would just recommend is OpenAI API key, right? And then create a OpenAI API key, right? Anthropic API key, right? You go here, you're going to get the Anthropic's API key, right? Google API key. Theirs are kind of different. So I'll put Gemini and then boom, get your Google API key, right? Grok API key. They get your Grok API key, right? So I'm not going to click on none of these because they're going to go to my data. And again, we don't share keys here. So that's how you can get your API keys. So we're going to be using API keys in order to talk to these servers, in order to talk to these LLMs to bring back the data we need, right? I was talking about, so we understand the price. So we're going to be using ChatGPT, the O4 or the O3 mini models, right, in order to process and prepare data for review. And then who do we want to actually review it? Do we want Anthropic to review it? Okay, Anthropic. I'm going to be using the Sonnet 3.5 model to review. Again, Anthropics is not cheap. I'm not going to hold you. Anthropic model pricing. No. Sonnet. Beautiful. Bruh. Anthropic API model pricing. Model overview. Here we go. So I only use Claude 4.5 when it comes to coding. Yes, I can use Haiku, but who wants to do that? What I'm going to use is choosing a model. All right, where? Don't make this hard. Don't make this hard. Don't make this hard. Pricing. All right, so here are the models. Let me zoom this in so you can really see. What I'm going to be using is Sonnet 3. Okay, they don't have 3.5 anymore. Y'all done deprecated 3.5? That sucks. Hold on. All right. What we're going to do, so that's crazy. They done deprecated 3.5, meaning we can't use it anymore. 3.7 is deprecated, bruh. Because of 4. Because they just moved up. I'm going to try. That's crazy. So y'all said I can't use it anymore. I got to use 4. The prices are the same. Yeah, the prices are the same. All right, so we're going to be using Cloud 4 in order to models deprecated, meaning, bruh, 3.5 held me down. Oh, that's okay. So y'all just 3.5. Yeah, y'all just did it. Yes, this week. Damn, OPS is about to be so deprecated means like they're taking it out of rotation, which kind of sucks. They just retired my dog. They just retired 3.7, so we gotta use 4. That's crazy. They're about to retire Opus. That one is still kind of expensive, and that sucks that y'all are doing this. I'm not gonna hold you. So I guess we're going to be using Anthropic's Anthropic Sonnet 4 to review the data and recommend. Prepare. All right. What I need to do is 2 seconds, fam. 2 seconds. 2 seconds. 2 seconds. Thank you for not doing it. Thank you. Thank you. Thank you. So what I need to do real quick is hold on. Boom. I need to bring in my API key. So we're gonna open the project. We're going to open our AI agent. That's just a new folder, right? There's nothing in here. Now, again, we don't share keys with NetTBT. So what I want to do is just bring this off screen real quick so I can put in the API keys. Hold on. Where is it? Perfect. We're going to call it .m. And again, we don't share our keys with nobody. All right, our .m file is there. And then now I just need another file so we can open it up. Okay. We're Gucci. So we have our files. We have our .m file that has our API keys. Remember, we don't share our keys with now person. If I need to bring the keys down, then I will. Okay, so right now, what we're going to do is open up Claude Code. So I can close that file. We can close this file. Again, I like to use 4.5. So I'm going to close this out. Let's go get the command in order to get 4.5. Let's make sure we're Gucci. We're Gucci, fam. Let's get our command in order to get 4.5. All right, perfect. Now that's going to open up. Y'all just bear with me for 2 shakes of a second. Again, if you do have any questions, please let me know. what I'm doing is I'm just checking one more thing. Are you cereal beans? Hold on. Yeah, thought that was gonna work, fam. Oh, what the heck are we doing here, brother? Stop. Um, Perfect. Give me 1 second. All right, and we are Gucci. Just checking one item. I just want to make sure the keys are great. All right, keys are Gucci. Keys are great. We're great. You're great for your patience, right? So we have Claude Code open. So again, the way I like to use any LLM, right? I like to treat it like we're in a deposition. So if you're, I haven't been in a deposition, but I like to watch legal dramas, right? Suits is my favorite one. So if you ever been or seen a deposition, right? Attorneys, lawyers, prosecutors, whatever you want to call them, right? They're not going to ask you a question. You ever had? Okay, I've said that a lot. They're going to ask you a question, right? You saw how I enunciated that. Ask. They're going to ask you a question, right? That they're not going to know the answers to, right? So 80% of the time, like they have an inkling to what that answer is, right? But they're going to ask you anyway to be able to get it on record, right? So that's what we're doing here. I'm going to ask Claude a few questions about, okay, what's the difference between an AI agent and a RAG agent, right? And how does it work, so on and so forth, so we can build context. Then once we have enough context, then we're going to get into the crux of the project here and to being able to build our AI agent using the multi-model approach, right? And you're going to see how that's done. I'm going to make this modularly, meaning that each file, so ChatGPT is going to have a file, Anthropic is going to have a file, Gemini is going to have a file, right? And then we're going to create a workflow that brings all of this together. And then we're going to make it such that it can run autonomously. And maybe I'll create a web interface. I don't know. We'll see how crazy we get with these things, right? So let's start by saying, can you tell me in a creative manner what is the difference between a RAG agent and a AI agent using only 228 total tokens for your output? Remember, it's talking about tokens. Like, I don't want you to use all your tokens, bro. Because every session, even though I'm on the max plan, but every session, right? Like you're using tokens. So these are little tokens that I use. 228. Bet. Excuse me. I ain't trying to cough in your ear. So yeah. Fetches retrieve. Okay, we talked about that. Autonomous. Blah blah blah. Blah blah blah. All right. Perfect. Now we want to create an hybrid AI slash RAG agent that is able to review our Algo bots trading logs, backtest, review the performance, and then analyze and provide recommendations based on that performance. Here is an example of one of their logs. Use grep and awk. These are different search commands, Python search commands via terminal command to understand. Then let's discuss let's discuss the agent's framework. We are thinking about the following for LLM models. Let's go ahead and bring this in. Want to use a multi-model for this. Let me give you an example of one. Perfect. Let's come back here. Here is the example of the log. Now review and then let's discuss. This is just part of my process. I don't want to see it. See, it's grepping. It took everything. It found everything. It's searching everything. Then it's looking. It's saying, all right, bet. This is what you want. This is how I'm going to look at it. These are the fields. Oh, I gave the one that actually traded. Perfect. All right, let's look at the plan. Okay, analysis, MeanieBear, 0 DTE, SPY options, momentum breakout strategy, runtime from 9:40 to 11:40. I ran this today and I ran it on our um on a Twitch. So if you follow us on Twitch there, you can go see it. Results, it lost 15%, so it went from 100 to 86, $84. It was one trade and two cancels. Key data points in the log, the strategy parameters, the entry and exit rules, the risk management, signal detection, volume breakout, trade execution cancellations, real-time P&L tracking, VIX levels, market conditions, 5,300 logs, the hybrid risk agent. So Gemini is going to parse the data file, handles 1 million plus tokens, right? That's one thing I love about Gemini. Like it can handle the tokens without problem, right? When we talking about 1 million plus, ChatGPT, nope. Anthropic, nope. So data ingestion, you're going to bring in the data, extract the trades, the signals, the P&Ls, timing, errors, and aggregates them across the logs and the bots, and then structure them in a time series data. And then data preparation calculates the metrics, the win rate, the Sharpe ratio, max drawdown, profit factor, identify patterns, entry patterns, signal clarity, slippage, generate statistical summaries, generate summary tables across runs, and then Claude Sonnet analysis and recommendation, or review the prepared data, analyze the strategy effectiveness, identify the failure points, cancel false signals, and then recommend a parameter adjustment, risk management improvement, market condition filtering, RAG process, vector DB, store. So that's our vector database, right? Store the hybrid performance and successful trades, retrieve compare performance to the recent, and then, all right. Hold on. Should we, and not saying that we have to, right? But should we build context on each of the algo bots we have? Also, we want this to mimic RAG. So, all of the bots after the run outputs their logs in their respective folder. So the agent, Gemini, in this point, we would need a process where it can automatically find the new logs, then do its job. Here are where it would be. Here is where, not R. Here is where. That's only, bro, that sounds weird. We have Belair. Who else do we have? We have Printer. Who else do we have? We have our scalping. Who else do we have? And then we have QQQ. Here is what the logs look like. You already had Belair. You've already reviewed What is that? MeanieBear. Here are the rest. Well, we not nerds. Here is the log. And then last lotto. And then I want scalping. Here's Belair. And then we have QQQ. And here it is. Now let's discuss before we begin coding. We're getting somewhere. We're getting somewhere. All right, bro. Like nobody's running you right now. I don't know why you're spazzing, fam. Don't know why you're spazzing, fam. I just want to sing. All right, let's see what you screaming. Let's see what you screaming. That's a lot more tokens. Now that we understand how tokens work, but look how many tokens it's using. But the thing about using Claude Code, we really don't pay for tokens, right? You just pay for the session. Maybe I'll get into that in a little bit. Okay, here we go. Strategy MeanieBear is a 5-bar breakout momentum strategy. We have LottoBaby is a momentum lotto strategy. We have BelairBaby, a 2-bar momentum scalper, and then we have QQQ, a 5-bar breakout with a VIX filter. Logs day, total, structure across 4 bots, auto discovery, watch folders, okay, and then it finds it. Perfect. Process. The file watcher detects new logs on the bots. The shutdown daily parses the logs. Each bot has a unique name. Extracts the trace, the signals, the poem, and then store and structure DB. The context building, yes, essential. Creates a bot profile and the vector DB. Strategy, rules, entry, historical performance baseline, known failures, market conditions, parameter sensitivity, and then analysis pipeline. Gemini long context, ingest the full 2 dBs daily, log dump, cross bot correlation. Did all bots struggle today? Extract the anomalies versus the historical patterns. 4.0 process, fast processing, calculates the metrics per bots, compares to the baseline performance, flags outliers, unusual losses, order failures, prepares statistical summaries. And then Claude is going to analyze the prepared data, root cause analysis. Why did MeanieBear lose 15% today compared to RAG context, similar context conditions, blah, blah, blah. So the RAG knowledge base is the store. Historical daily performance by bot, the successful and failed trades with market context, previous recommendations plus outcomes, the parameter optimization history, retrieve on similar market conditions, similar patterns, and similar. Okay. So key questions: run the analysis after the bot stops, or batch nightly. Maybe a combination of the two. Storage is SQL for matrix, and then so SQL Lite and then Chroma DB is a super easy way for us to be able to do this where it doesn't add complexity. We can just use SQL Lite, and SQL Lite is a built-in database that comes on everybody's computer, right? And then Chroma DB is a built-in Python vector store that anyone could use. So we could just use these two and get it done. And I think that's good enough. But if we grow, we may need to bring it over to Pinecone. And I showed you what Pinecone that I just added complication that I don't think we need here, right? So I'm just going to keep it to Chroma and then SQLite. Output the daily reports, Slack alerts, interactive dashboard. Maybe I'll do a daily report and an interactive dashboard. Let's see. Back testing. Should the agents recommend parameter changes and then back test them? No. That'll be cool though. I don't want that. Auto execution, just recommendation, or auto adjust bot configurations. So, your thoughts. Want to start with auto discovery, then context building first. Before, let's answer your questions. One, we want to be able to trigger it, but also once things go well, we can set up a cron job. A cron job is an automated way to be able to run these agents where we don't have to click it and for them to run. So they run automatically like every day at 4, right? Go pull the logs and then go do your job, right? Job for this. 2, we are thinking we can start with using SQLite and ChromaDB for now. No need to complicate it, but we must make sure ready to be used and no issues there, and not using other DBs saved within SQLite or ChromaDB. 3, daily report, and maybe based on how we are coding today, a cool interactive dashboard as well. Maybe. Nope. Just recommend for now. 5. Just recommend for now. All right, let's see. Damn, about 1,500, bruh. That's a lot, fam. Clear constraints. Let me structure the implementation plan, system, hybrid, manual trigger, cron in the future. Log discovery and ingestion. Gemini scans the 4 bots folders, parse the latest log, extracts the trades, signals, PNL, and then the error. Storage layer, SQLite, and then ChromaDB. Super simple. Analysis pipeline. Okay. Then RAG, all right, Claude, root cause and recommendations, output, daily markdown report, and then optional interactive dashboard. So this is going to be back end, no front end right now. Okay. Entry point. Hold on. Can we make this CLI? CLI is terminal. CLI based. How can we improve UX UI before we get started with this work here? And let's just copy our keys. And then next thing I'm going to have them do is before just lay out the plan. Bruh. There's Nathaniel there for you. Another 1,500 words. That's crazy. I'm not going to hold you. Bruh. 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 I just want to see him. Yeah, it's not what I wanted to see. Da-dum, 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 da-dum. What am I looking for? I'm looking for you. Okay. That's funny. That's funny. MeanieBear last 7 days. Performance. Oh, look at that. Look at that. I love it. I love it. So we can run this out of the terminal. The core library, rich and beautiful terminal. Elegant CLI plus Y-span spinners for long operations, questionnaire interactive prompts. All right, analyze the latest bots run and then generate the reports, monitor the folders, right? Report, start command, test the API connection. Look at that, bro. Version, first setup, man, run it. Look at it, man. I love it. What y'all think? I like this. I like this. I like this. Daily performance report. To cancel. Let's figure out why. Full trade. Export. All right. Statistics. Analysis. Color coded. Rich. Okay. All right. This is perfect. Now, before we get this done, lay out a plan / to-do list so we can follow before we start coding. Something you gotta have, bruh. And then once we start coding, that's going to be a little bit faster. I just wanted to flush this out, and then once we flushed it out, we can actually get to the work at hand, fam. Should I create a separate content environment for this? But it's under, no, I want to keep it under the little option gang. So I want to keep it under the content environment that it is right now. So, and content environment is like a garage, right? That you place your code of your projects. And I can create another content environment for this, but I like where it's at right now. So I don't wanna, we don't gotta overcomplicate it, bruh. We don't have to overcomplicate it. We just keep it simple. You see me? You see me? We don't gotta overcomplicate it. Bro. That's crazy. I didn't expect you to like take that long for a little plan. All right, here we go. Let me see right now. Environment setup. Okay. For environment setup, and that's why I have a content environment. So perfect. Yes, but forgot to mention we have, so you can use this in lieu of creating another virtual environment. And here are the API keys and the .m file. Listen, we are streaming now. So that means do not share the keys in the logs or anywhere that may be a security risk. Got it? Perfect. Let's proceed. No cache functions, no mocks, no fallbacks, all real implementations. After each step, make sure to test to ensure working before going to the next. No mocks. You gotta set the stage and you gotta let bruh know that, listen, I'm on the World Wide Web. Like, I don't need the World Wide Web knowing my keys. You see me? Oh, let me go ahead and hit auto, so you can just run. We don't need the World Wide Web knowing our keys. All right. Oh, look at that. So everything is coming together. Look at that. I told you. Everything is coming together. Everything is coming together. All of our files are coming together. And now we're just going to let the AI work. AI is creating AI. Ain't that funny? We're using AI to create AI. We're using AI to create AI. It'll be funny if, like, every time you said that, like, Allen Iverson popped up. What you talking about? Just being stupid. Whatever. We're using AI to create AI. And right now it's installing the packages that we're going to need. Now it just wrote the configuration file. Now it's going to test that configuration file. Let's go take a peek at it. It just said, okay, these are the bot folders. Here are the constraints it just wrote. So I love it. It's going through this quick, fam. Okay. Log patterns, OpenAI. Okay. I love it. So we're running. Setting up the project infrastructure. All right, so I'm going to let this bot run, or this bot. I'm used to saying bot, but I'm going to let our AI finish creating AI. I'm going to let AI finish creating AI. AI creating AI. And again, I could have used, and I don't like using them because they bring complications for no reason. Maybe one day I'll do it where we're going to use LangChain. Right? A LangChain is a framework that you can put your AI agents in, right, to be able to have them do their jobs, but I'm not going to do that. Or we can use Crew AI. Again, Crew AI is another framework that you can use in order to build AI agents. But I'm not going to use, did they get, what did you do different? What did you, because they just updated their website. You see Crew GPT? That's funny. I'm gonna go look. Oh, it's basically the same. I just different colors. I don't like create again, just complications for no reason. There's also Llama Index. Um, Llama Index is primarily for like RAG agents. So there's all of these different frameworks that we can use. So framework is like the car, and the AI LLM model is the engine. So we can put these engines in these different frameworks, right, in order to have them run, but they add complications. So I don't like using them way too much, especially if we have a very focused idea of what we're doing. Bruh, what's going on? We're using AI to test AI. All right, come on. Okay, there we go. So all of the keys are working, which I knew it was going to be the case, but you just had to get yourself right, man. Now let me update the config and then move to phase 2. Perfect, perfect, perfect. Storage layer. All right, all API are working. Now let me move to phase 2, storage layer. All right, so I'm gonna let this work. I'm gonna grab some agua and I'll be right back. I love it that it kind of needed me to test it, but all right. You can get me right. Test our storage. You want to make sure everything is testing well, right? Let me go look at our storage. All right, perfect. Market conditions, excellent. Storage was working. And I love it. Everything 200. Models. ID name. Storage is working. Now let me move to phase 3, log, discovery, and parsing. Perfect. Let me look at the SQL manager. Let's bring it in the SQL library. Storage model. I love it. I love it. I love it. All right, fam. We're on it popping. Let's test the discovery. Can you get the, okay, perfect. The discovery works. Now let me create the log parser. This is a big one. This needs to parse each bot's unique log format. Ingestion, okay. We rocking data. We rocking data. Now let me test the log parsers. And I love this when it works like this, man. And creating agents are some of the easiest things to create. I'm not going to hold you. Like, it is not difficult at all. And especially when you use Claude Code 4.5. Excellent, excellent at being able to code. And you're seeing it here. It's kind of coding it like the opposite of TDT, test driven development, TDD. I normally can use TDD, but whatever. Next time I'll use TDD so you can see that. So it found an error. Great, the parser is working, but the starting balance is wrong, showing 2015 instead of the 100. Let me fix that. Perfect. So it found an error and then it's fixing it. Still showing 2025. I see the date 2025 is at the beginning. So let me fix it. Perfect. The parser is working. Now let me update this to do. Move to 4 AI integration. Due to the token limit, I'll create a streamlined version. Wait, hold on. What do you mean? What do you mean? Streamlined version. Explain. You know what I forgot to do is the token tracker. That's what I'm going to add as well as a token tracker. Instead of streamlining it, what I meant by streamline version, I was concerned about the token usage. We're about 70K to 200K tokens, and I wanted to avoid creating overly complex AI integration code that might have redundant features, complex catching, fallback mechanism, retry logic that explicitly says no to over engineering prompts have huge multi-step chains when similar won't work. What I should do instead is create a focused production ready AI integration that Gemini's the extractor, takes the large file, extracts the structure, trade signals, and the error data. The GPT metric calculation takes the parse data, calculates it with the win rate, blah, blah, blah. My plan forward, should I continue with the what you wanted or show you the architecture first, then code it and see if you like it? What's your approach? All right. We are good with that, but we forgot to bring in the token tracker for this. So let's update and include it in the plan so we can stay aware of the token usage, both input and output across models / providers. We repping. All right, perfect. I think it's just gonna bring in like a tokenizer library, but nonetheless, we're working, fam. Like in another 20 minutes, 15 minutes, we'll be done. And then depending, fam, stream health, be healthy, be Gucci, we screaming. We working, y'all. Like we are doing this thing. Okay. Perfect. Token tracking is critical. Let me design the implementation first. The API call, provider, model, input, output, token cost, purpose, run ID, token tracker. Okay, perfect. I love it. Just keep us aware of everything that's going on. Keep us aware of what is going on, fam. I need to fix that because that shouldn't be a problem. It really shouldn't. That shouldn't be a problem. It really shouldn't. That shouldn't be a problem. It really shouldn't. I'm talking to myself, so don't worry. Man, this thing is looking great. I'm not gonna hold you. I ain't gonna hold you. I told you I did it. And right now, okay, perfect. The token tracker is working. Now let me create the AI integration wrappers that uses the token tracker. We have the Gemini, and Gemini's Google's AP, the LLM model. Now the GPT metric calculator. There's one more thing I can do to be able to make this, like, take this over the top, but analysis, integration, analysis. Now Claude recommender. So about another 5 minutes here, we're going to be done with this code. And we're going to see it live, how it works and what it does. And then depending on just depending on usage, I don't know, depending on how I feel, I may just create another strategy right here live with you all, because I have another idea that has been germinating that I want to create with you. So I may just test that out. We'll see. But we're doing great work here. If you all do have any questions, comments, or concerns, you can write me know and let me know. But nonetheless, we're finishing up our AI agent here. And this is an AI agent that is going to be reviewing our algo bots, right? MeanieBear, Lotto, Belair, and our Sniper, right? So we're creating a multi-model agent, and the models that we're using is going to be OpenAI. We're using Anthropic. Providers we're using, and we're using Google. Now, I could use Gronk, but I've already decided we're here. We're here. We're here. Perfect. The recommender. Where is it? Analysis. Recommender. That one's code is a little bit long, so I want to go look at it. Looks like it is. Describe 2 or 3 sentences. Recommend. Be specific and actionable. My recommendations. Oh, it's only 200 lines. That's a bet. Perfect. All AI models modules are created with tracking. Let me create a comprehensive test. Now let me test the full. What I want to do while it's running the test, I want to go put eyeballs on something real quick. Doo-doom, doo-doom. Bro, like I really gotta fix you. This is just getting outrageous. Okay. That's not bet. Bet. Just say let me update the um all right, perfect. Let me update the to-do list. What's working, the storage, log parsing, AI, Gemini, GPT, and then Claude. Cost per analysis is about 4 cents. That's very cost effective, especially using three. Um, I'll let you in on a little secret, right? You don't pay for tokens as heavy on Gemini as you do for GPT and Claude, right? Most of this is probably coming from Claude. I'm not going to hold you, but I'll look when we're looking at the actual recommender. So the actual report. So all right, let's proceed. Let's proceed. I did not know you can do that. Bum. Um, are you gonna go? Oh, let me create the mini. Okay, the rag retriever. So we have our rag retriever that's going. Um, bro. Sometimes I okay. Um, I'm gonna come back and figure that out because this is just redonkulous. But. That's not what I want. No, that's not it. All right, so we have a couple of errors that we have to fix. Doesn't allow metadata, so let me fix that. That'll be perfect. All right, just waiting for this to go. So let me go ahead and run you. All right, we're almost done here, people. We're almost done. We're just processing, and that's crazy, bro. I was just using. So I just wanted to look at the logs, but we just saw here that they're deprecating 3.5. I was just using it. That's fine. That is fine. Gemini rate limit. Let me add a small delay for now and then test one bot to verify. What rate limit are we hitting with Gemini? Explain. We're hitting a bit of a rate limit. That's fine. That's expected. Let's check it. Let's see if we can make this a bit better. Yeah. Let's see if we can make this a bit better. Yeah. And it should be. All right. The problem is that the Google API is a 429 exhausted, called 4 times, once per bot, called one for all, total 5 API calls in rapid succession. The free tier, right? What we're using is 10 requests per minute and then 4 million tokens per minute. We're hitting the 10 RPM requests per minute because we made 5 calls too fast. If we ran this twice in a minute, we hit the limit. Why it failed? Solution 1 is add a delay between calls, wait 6. Then max switch to Gemini. I'm not doing that. Process all 4 in one API call instead of one. Can we do the batch instead of rate limit with delays? Which is better to get done? We have a thought. Want to compare notes. I got a little inkling, bruh. I have a little inkling. Just right now we're hitting limits is because we're trying to process all 4 of the bots at once instead of having a little delay. And I'm fine if we can update it to have the delay. That's no problem, right? I just want to compare the notes. I'm thinking batch. I think batch would be better. Let's see. Batch is doing it instead of sequentially, one at a time. We do it all together. Excellent question. Let's compare batch processing, API call, cheaper, large prop context, all 4 logs concatenated. Need to parse the structures for all 4 bots. If one fails, might all fail. Rate delays, slow 6 seconds, 24 seconds wait time. Batch is objectively better for your use case because you analyze all 4 bots together. Makes sense. Speed matters. You want daily reports fast. But with batching, is there a chance that we can get the reports mixed up? Should we just add the delay between, I just thought about that, between request instead? Can we have a faster one than 6 seconds? Can it maybe be 3 seconds or 2 seconds? Let's discuss. Stop bloviating me, fam. Stop bloviating me. Da-dum, 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 da-dum. Need assistance, fam. Oh, so I was trying to do two things at once. I had to send out a message, and then can reports get mixed up? Low risk if we structure it properly. How to prevent mixing? Analyze for bots separately. Return the JSON. Bot 1, bot 2. Risk if the logs are very similar. Gemini might conflate them. And if the JSON parsing fail, we lose all 4 bots. Delay. Can we go faster? 6 seconds, 3 seconds. We'll hit the 429. Reality check. The pipeline makes 5 Gemini calls per analysis run. A 2-second delay is the 10 request will fail. Is the 6 seconds, is the 10 just safe? If you run the analysis twice within 60 seconds, even a 60-second delay might fail. Hybrid, batch per bot, 4 calls instead of 1. Keep cross bot analysis separate, and then add the 6-second delay. So batch to extract all 4 bots, 1 Gemini call, and then a safe buffer, and then cross analyze the bots, 1 more Gemini call, a pure batch, no delays, fastest, slight mixing risks, pure batch, safest, slowest. Wait, hybrid is hybrid batch plus the 7-second delay balanced. Can we do C with, all right, let's go with C and make sure we can mitigate the risk of logs being cross contaminated. We rep in theta. Bum 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 bum. Da 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 da. Oh yeah, let me go ahead and make that auto. Perfect. Option C with delay. Let me implement. We're just adding a delay so we don't run into the 429 errors. The 429 errors is when you rate limited. Because we're using the free version of Gemini, we were bit rate limited, right? I don't need the pro version. The free version is just fine enough. You don't have to pay for the keys, but they do limit you. But you don't have to pay for the tokens, but they do limit you. Now let me update. We repping theta. We repping theta. Now let me rename and then update the bot analysis. All right, let's test it. Let's see what you're screaming. Let's see what our analysis yields. You zill me? I really need to take care of that. Like, really. There's this IBKR warning that I need to take care of. After we're done here, and I'm just going to use this as a time to be able to get all this other stuff right. And Mayuchi. So I'm waiting on the code to output. What it's doing right now is testing the updated way that we're going to process the reports, right? So it's taking 3 minutes to do this. It should finish like in another 20 seconds. It's been about 75 seconds. So we should be done in a bit here. You should be done in a bit. And then after it outputs, we're going to review it, gauge its performance, button it up, and then check how it looks in the actual terminal, right? Because we want this to be terminal based. And then we are going to run. So you all are going to see the process of being able to actually create an AI agent, how we went from like breaking it down, understanding what it is, how it works, and the different elements of it. Perfect. It completed. Damn, I should have watched. It was just under, I think, just under 2 minutes. Just under 2 minutes it completed. Success. The batch is working. All four are analyzed. No contamination. Only 2 calls and cross by. Okay. Down from 5. 7-second delay. No errors. Total cost was 16 cents. That's crazy. We went from 4 to 16. Market regime detection worked across all bots much faster than the 30-second delay. All right. Gemini's 170 tokens, right? Still free. 5K and then 22. See, the most expensive one was Claude. Bruh. Like, I gotta mitigate that. I'm gonna figure out a way to be able to mitigate that. Cause that's crazy. Can botch process lead. All right. Let's proceed. That's crazy, fam. 16 cents for one run. I mean, I told you Anthropic was the most expensive one. I just didn't think it was gonna hit me over the head like that. Thought you was gonna warm the kid up to it. Nah, you just like boom. I'm just damn sure was 16 cents. Let's see. The fact that y'all are main, I may have to switch, but I don't want to. But bro, is this? I want to use it, but like I ain't gonna be hit over the head with it. You see me? Make it executable. Yeah, you put 6,000. Nah, we gotta mitigate that, homie. We definitely gotta mitigate that. All right, let me get a terminal up so we can see how this is gonna work in the terminal. This is for our other bots that we are working. Let me get a new one. Let me just put that there. Hold on, I should have done that because you know why? Hold on. Was I talking all this time and you couldn't hear me? Bruh, I was so talking all this time you couldn't hear me. I hit the mute button and it was on accident. Was I talking all the Yeah, I hit the mute button. It was on accident. I hit the mute button on accident, but now I checked myself. We're Gucci. I'll let you test it. Let's look. Um, all bots, number of days showing. Okay. Here we go. I just wanted, okay. We noticed that we have to put the command in the line, right, when we run it. But we want it when we run the main.py, it pulls up everything, the menu, etc. And then we can go from there. I mean, you can keep the CLI, but we want it when it's ran, pulls up the entire menu so we can operate from there. All right. So let me just wait for that one little update. And then once that update is there, then we'll be able to, you want a main menu that appears when you just run Python that main without any commands. Let me create that. Let me create dot. So if I put Python main.py, beautiful. Beautiful. If I want to test the API connection, beautiful. So the test is working. If I want to initialize the system, system is initialized. If I want to check the version, version is checked. If I want to view past, let's check Meanie, number of days. All right. What about being able to review past reports that are saved in SQLite? We want to be able to review this as well. Do not think we can as of yet. Look at this, man. This is fuego. I don't want to analyze a report, so let's just exit right now so we can have that part of it up. And then we have our AI agent, ladies and gentlemen, that we can run in our terminal. You're right. We're storing report in SQLite, but not generating the saved reports yet. Let me add it. Report generation, save to file, report viewing, read past reports, and then menu option to review them. I love it. Then we have our AI agent that's going to review our reports. Now, the only thing, I'm not going to hold you, that Anthropic bit is needs to be mitigated, bruh. Like being able to pay 16 cents per run is not cost effective. We're not rolling in it yet, so I have to be able to make sure I mitigate these costs as much as possible. So if you do have any questions while we're going through this process, please let me know. You all are seeing how I do it, right, when it comes to being able to create an AI agent. And I'm excited that you are all able to see this. So I'm just going to keep this focused on AI agents, and maybe I'll come back a bit later when it comes to being to create the actual another strategy. But we're Gucci. We have it. We are fine. You know what I want to check is, Because Anthropic real deal cost 16 cents, bro. Whereas OpenAI only cost not even 2 cents. I don't even think 2 cents. Not even 1 cent. I put the same amount of data in there, bro. It's just crazy. All right, we're at the part where we are practically done. I'm just waiting for the final part of this bit. And then once it's done, we're going to test it. We're going to make sure that it works. We're going to actually run a report. And then once we run the report, review it. And then after we review it, then I'm probably going to look at it and then mitigate these anthropic costs. I ain't going to hold you. That's just the only thing I'm like, ugh. But everything else, I mean, is Gucci. So you saw how we did it. We used AI to create AI, which I love this and is fantastic. So this is part of my process. Well, this is what I do. This is how I do it. I do this daily. So if you want more videos like this, man, don't forget. Okay, report generator. I'll put report generator. Okay, perfect. All right, it's going to add the report generator. I love it. So once we have our report generator, we're going to be ready to go. And I've been wanting to create this, so I'm glad that you all were able to see it. Our AI bot is, our AI agent is Gucci. It is doing everything that we need. It is allowing us to be able, perfect. I'm going to get an opportunity to run this here with you all so you can see it, run an actual report. Again, the only thing that I'm noticing that I want to fix um, is the cost to Anthropic. That's it. It's the cost to Anthropic. I'm like, bro, that's just a bit high. Oh, you know what you're not showing me is the, also make sure to include the token cost as well, so we can review and see that in the menu. All right, let me just go look. Let me just go look real quick. View past reports. There's no past report, so we got to run it first. I'm about to go run it. Just give me a second. I want to make sure we get the cost there too, so we can understand the cost. Now the reports will show the token cost. Let me update and create a final summary. Main.py. Look at that. All right. Perfect. Now let's run it. Analyze. Today is the 31st, but okay. Oh, look at that. That's dope. Discovering the logs. It found it. It's parsing the logs. And then it is parsing the logs right now. So while that's doing that, we notice that the Anthropic Claude recommender costs are a bit high compared to the others. How can we mitigate so it does not surpass 8 cents? Like approximately 8 cents, right? I'm willing to pay 5 cents, bruh, per run. Review and advise first before we proceed. with changing code. So it's running. It takes about 2 minutes for it to run. Remember, we ran it before. It takes about 2 minutes for it to run. So I'm just going to let it run. It is parsing the logs, and then it's next going to say extracting the data. So let's allow it to run. While that's running, I'm going to go grab some more agua. I'll be right back. All right, the report ran. Let's go look at it. Let's go look at it. Um, Intermediate, the data is insufficient to definitely characterize the market regime. The presence of the VIX values around 16 suggests a reasonable, stable market, but the high error rates and lack of trading volume from several bots hint at potential underlying instability or algorithm incompatibility with the current market conditions. See, it costs 24 cents, bruh. From that's a lot. I'm not gonna hold you. View past reports. We can view the report. All right, here's the report. All right, one trade. MeanieBear suffered a catastrophic 15.3% loss in a single trade with 0% win rate and severe execution issues. Hold on. Execution issues, which require immediate suspension and then a comprehensive reconfiguration before any further trading. Severe execution issues. Okay, I'll fix that. LottoBot experienced a complete system failure on 1021, executing 0 trades due to the IBKR market connection issues. This represents a critical. So that's another thing I gotta go for. Okay. Is this the same thing? Experienced 12 errors related to the underlying current close right variable and the momentum detection 0. So okay. I like this because then we could run this every day and then figure out what's wrong, how to fix it, and get this done. Immediately halt trading. So the same IBKR. Common issue is the high error rate across multiple bots, suggesting potential issues with the market feed, API connectivity, or code bugs. The lack of trade activity for Lotto, Belair, and QQQ, despite having some VIX values. Best performer is Lotto, Belair, and QQQ are tied. All these bots registered 0 PNL, suggesting minimal loss. Okay, worst performer was Meanie. That 25 cents is a lot. So let's see what we can do to mitigate that. I told you Anthropic was expensive. long prompts. There was this hybrid mode that you recommended. Hybrid. Switch to for pre-bot recommendations and keep for only portfolio. 1 API call. Max to 3,000 per bot. Okay. Per bot recommendation and then portfolio recommendation. All right, I'm going to get back to this soon, but you see here we have some work to get done for our bots themselves, but in essence, the goal that we wanted was complete, right? I wanted to create an AI agent that is able to tell us, okay, what's up with the bots? How can I fix, you know what? I need to exit real quick so I can get the cost. So let me exit and then it should load the cost so we can see that main.py. Oh, it says it in the reports. Okay, it says it in the report. All right, so we have our bot. We have our AI agent. So our agent is good. It's up and running. I just need to tweak a couple of things as far as the cost is concerned. You all don't care about that. You just wanted to see that the agent was good. So it's good. It's running. And then now I'm going to take these recommendations and actually fix them. So I'm going to go ahead and do that, and then maybe I'll come back on later to show you what we've done and what we've fixed. But if you all do have any other questions while we're going through this process, go ahead and let me know. These are great times that we're going through, right? Because you saw how we could use AI to create AI, right? And it gave us something that's completely comprehensive that I'm going to use practically daily for our bots, right? So it is your